Greetings, I'm Salvador Cordova. I am a researcher in a variety of fields, currently in molecular biophysics and biomolecular engineering. I have 5 science degrees. I'm presently a PhD student in biomolecular engineering. And I have published in secular peer review. So I'll give you a sample of some of the areas I've published in. They are available through most university library systems. For example, my most recent publication was through Oxford University Press in the field of structural bioinformatics. That was in 2022. I've had publications since then, but these are a little bit more high profile. I also published through Springer Nature, and in a reference work I published on dynamical systems, the idea of fitness, which is population genetics, and in evolutionary biology. It was a 70-page chapter in that reference work. By the way, the book it was published in first retailed for $1,500. But just visit my YouTube channel. You can get most and even more of my ideas for free. My biggest quote unquote claim to fame was when I was in the cover story of the April 28, 2005 edition of the prestigious scientific journal Nature. So there on the left is the cover, and there on the right is yours truly in the cover story. That was me 20 years ago. So I'd like to thank everyone for tuning into this YouTube video. Why I am making this video is to both announce and share with you a presentation that I made at this major evolutionary conference. Yes, I am a creationist. I'm a creationist, but I presented at this major conference. It is the conference is Evolution 2025. It is still ongoing. It started officially on May 29th. It actually, the preliminary started as early as like May 26th. It was insane. And it's continuing right now. They are spooling up for the major events, which will go from June 20th to 24th. And just to prove to you that I was there, just go to this website. By the way, it's sponsored by the Society for the Study of Evolution, the American Society of Naturalists, and the Society of Systematic Biologists. Now, there's one cute thing about this. You see this stained glass window, and it has kind of all the, kind of evolutionary icons there in the stained glass window. So this gigantic gathering of mostly evolutionary biologists and other scientists, about 1,000 of them, it has this feel of a big congregational church meeting. It just definitely had that feel, and I have to admit that a lot of practically everyone that I met there, they're really the sweetest people. They're wonderful human beings. You'd want to hang out with them and go to school with them and work with them. They're very wonderful and welcoming people. Even though we are, my viewpoints, both metaphysical and scientific, are in almost diametric opposition to a lot of the views that they hold. They're very, very sweet people, and I feel some measure of regret that I have to call out what I think are flaws in in the practice of evolutionary theory. And I did that in my talk as politely and diplomatically as I could. Now, let me go back to the website. You can go to the website yourself, and you can verify all of what I'm saying. There is a virtual component, which means people can just attend and give talks virtually, and then there is an in-person component. So the virtual conference component has already completed. That was through May 30th. I presented on May 30th. The in-person is from June 20th to June June 24th. Now, I really, really wanted to go to the in-person conference, but let me show you they have some requirements that I had issues with, and you can probably guess. So there were requirements. You can see one of the requirements there, which I'm not going to say, but just for the record. Okay, wait, sorry. I failed to share my screen. If you go to the website, you can actually see some of the conference information, and you could see there's something I found a little objectionable in the conference information list, and their requirements for participating in an in-person conference. For the record, I have had 2,000 vaccinations in my life. I used to go to the clinic to get injections for allergy. I have had also vaccinations for diphtheria, shingles, flu, all sorts of things. But there was a certain requirement there that I had to provide evidence for a certain vaccination, which I had taken once upon a time, but have since ceased and desisted. And they wanted updated vaccination records. And you would not be allowed into the in-person conference unless you provided it. And I said, no, I'm not going to subject myself to that. I found it really funny because you'll be traveling. A lot of people are traveling through airports and restaurants to get there. But once you're there, you'll be refused. So, I mean, I just found that really funny. I really did want to go there online. But that being said, let's go back to the to Evolution 2025. To prove that I was there, just go to Program and click on Program, and you'll get all these links, and you have program links, apps, code, downloadable programs. And you'll see me in that program. So just scroll down, and you'll see the virtual PDF program. And let me see if I could do this. Let me just make this bigger. And in that program, if you scroll down, you'll see, man, there are so many presentations. In that program, if you scroll down toward the end, you will see me listed as number 1 in the session on population genetics theory. There were 4 other researchers from various institutions, wow, including the University of Chicago, that presented. So you could see on May 30th, I was scheduled to talk, and I did deliver my talk 1:30 May 30th. Now, what was supposed to happen is our sessions were to be recorded and then later released. For some strange, first they were recorded, they were supposed to be released internally to all the participants and registrants. And then after the conference was over, so I'm guessing like, say, July 1st, recording would be dumped on the Evolution Meetings website for public consumption. But for some reason, the entire population genetics theory session is missing from the archive that they provided me and presumably everyone else. I talked to one of the participants and I asked, hey, is our recording of all 5 of us, is it missing from your archive too? And as far as I could tell, he said yes. So this is an interesting development, which reinforces the fact that I am so glad that almost immediately after I talked and after that day, actually after my session was over, I recorded as best as I could, word for word, the talk I delivered. This was facilitated by the fact my PowerPoint in the notes section had my script. I literally read almost verbatim what I wrote, word for word, with a plus or minus a few ad libs during the live presentation. And when I recapitulated it right after the presentation, I re-recorded it. It was essentially the same talk because I read from a script, plus or minus a few sentences that I just ad-libbed in the script. The major difference is that I spoke 50%, 30 to 50% slower in that recording, just so that it ran smoother. All of us, all the presenters, in practically 90% of these sessions were given only 13 minutes to present on their life work, so to speak. So here's 10 years of work, and I had to try to summarize the most essential points in 13 minutes. Yeah, our time slot was 15 minutes, but we were supposed to talk for 12 to 13 minutes and give 1 minute for questions and answers. And almost everyone was going into 14 minutes and not having any time for questions and answers. It was just nuts. I'm not trying to fault anyone. We had 1,000 or so researchers presenting on their work, 1,000 or so researchers at the conference, and maybe 200 presentations. There's just no way we could fit all that in, even in a month-long time. The expectation was that if someone really was interested in what you had to say, they could watch a video of your presentation. They could play it in slow motion or pause it, look at the diagrams, examine the tables that you presented and the references. So all of us were just blowing through our slides. I mean, it was like machine gun mode. So if I had to present my work, just please understand, I'm compressing what would normally be an hour-long talk into 13 minutes, and this is true of everyone. So just go and watch some of the presentations. You'll see how crazy this was for certain presentations. Unfortunately, the population genetic presentations were all like that. Oh my goodness. I mean, you were just seeing these huge equations and they're blasting through diagrams and data tables. It was nuts. And so, but apparently, the recording of all 5 of us has mysteriously disappeared in the archive. We'll see if they're able to reconstruct it and publish it on their website. But for the sake of posterity, I am releasing a recapitulated version to the public. I'm happy to make, if you can all help me figure out how to make my slides available, I'm happy to give you my slides. You'll actually see the text, the slides along with the notes that have my written delivery that I read from a script. So as I applied to make this presentation, I was very fearful that given who I am, and I am publicly notorious for my criticisms of evolutionary biology and my advocacy of both intelligent design and creationism, that I would be canceled. So with much trepidation, I submitted an abstract. Now, the abstract, unfortunately, is not accessible except by me on the Evolution website. I mean, I can get there and I can see the abstract I submitted, but I guess just the way they structured the system, interlocutors can't see the abstract. But I will read it to you so you could see that the abstract that got me in is pretty much faithful, in my opinion, to the actual presentation I gave. I didn't do a bait and switch. I gave them almost a practical playbook of what I would say that was critical of certain aspects of population genetic theory and also Darwinian theory. I did it as politely and as diplomatically and in as scholarly a manner that I could. I referenced practically exclusively, to the best of my knowledge, only mainstream peer-reviewed publications, and usually from both top-tier authors and top-tier publications. I don't know that I really cited anything that was just really obscure in journals that have a reputation for crank stuff. I thought I had good mainstream publishers, good mainstream journals to cite, and some of the best authors themselves, like Richard Lewontin, William Biolek, Nobel Prize winners like Sidney Brenner. So I tried to make my case with stuff that should be defensible in a university environment. So with that, let me see if I can. Okay, so let me show you the abstract. And as I said, you can see that this is the Evolution 2025 website, but this is something only I can access on my particular profile page. But let me read what I submitted as an abstract, and then I'll actually give my presentation. The title is Incorporating Biophysical Benchmarks into the Notions of Fitness and Adaptation. The abstract reads, we report on ongoing work that builds upon our two previously published works, the fundamental theorem of natural selection with mutations, and dynamical systems and fitness maximization in evolutionary biology. Although Darwin spoke of the clumsy, wasteful, blundering, low, and horridly cruel works of nature, paradoxically, Darwin described certain biological systems as embodying extreme perfection and complication. In recent years, the field of biophysics has affirmed Darwin's observation of extreme perfection and complication in certain biological systems. For example, the bird quantum magnetic compass exceeds the performance of any human-created quantum magnetic compass. Other examples of extreme perfection according to theoretical or experimental limits in biology are the electric field sensing of sharks, quantum quasi-particle exciton transport in photosynthesis, the single-photon detection capability of the eyes, the energy efficiency of birds such as Limosa, lapponica, the energy efficiency of the brain, etc. Richard Lewontin put forward a daunting partial list of problems with the present notion of evolutionary fitness in the paper The Confusions of Fitness. I'm right here if you could see my cursor. To help remedy the problems Lewontin outlined, we put forward the idea that a more well-defined framework for characterizing fitness and adaptation is a framework that explicitly incorporates biophysical performance benchmarks as formulated by biophysicists, as well as engineers who study biomimicry and bio-inspired designs for high-tech applications. Furthermore, there is experimental evidence, especially in the domain of reductive evolution, and theoretical justification that Darwinian processes are anti-correlated in many circumstances against the emergence and maintenance of organs of extreme perfection and complication, as defined by such biophysical metrics. These considerations lead to directly observable predictions about the ongoing evolution of humans and other complex organisms in the biosphere. So that was the abstract that was presented, and now you will get to hear a recapitulation of the presentation I actually made that day. Thank you for joining, and please enjoy this presentation. On behalf of myself and my co-authors, I extend thanks and greetings to the organizers and participants of Evolution 2025. My lead author, Bill Basner, is an emeritus professor of mathematics. John Sanford is a retired Cornell research professor and a genetic engineer famously known for his invention, the gene gun, which, by the way, is in the Smithsonian National Museum of American History. Ola Hasjer is a professor of population genetics at Stockholm University and a distinguished mathematician in Sweden. I'm Salvador Cordova. I'm presently a PhD student in biomolecular engineering at Liberty University, with 5 previous science degrees, including a master's degree in applied physics from Johns Hopkins University. I was previously a senior engineer and scientist in the aerospace and defense industry, working for MITRE, before getting retrained in biology by John Sanford and studying at the FAES Graduate School at the National Institutes of Health. We report on ongoing work that builds upon our previously published works in population genetics, protein biology, structural bioinformatics, and unpublished works in biophysics. So, what brings me here today? What brings me here today? It is this comment by Richard Lewontin, who said, "The problem is that it is not entirely clear what fitness is." The problem is that it is not entirely clear what fitness is. And no concept in evolutionary biology has been more confusing. No concept in evolutionary biology has been more confusing. Further, he laments on the incommensurability of the original Darwinian conception of fitness with the definition of fitness in modern population genetics. I like that word, incommensurability. And it is my goal today to add even more confusion and more incommensurability to the issue of what fitness actually is. Just kidding. Apologies in advance that I have to blast through these slides. Lewontin's lamentations are also echoed by other researchers to varying degrees. I list some here that can be investigated further by re-watching a recording of this talk in slow motion. Sorry, but we presenters are all under tight constraints today, and we're just going to be blasting through slides. I recently queried Google Generative AI and asked, "Why is evolutionary fitness ill-defined?" It responded, "Evolutionary fitness is an ill-defined term because it's a complex, context-dependent concept that is difficult to measure and define precisely." Charles Darwin wrote of endless forms, most beautiful and most wonderful, organs of extreme perfection and complication, yet paradoxically he said, "What a book a devil's chaplain might write on the clumsy, wasteful, blundering, low, and horridly cruel works of nature." For Darwin, the process of natural selection resolved this paradox. Darwin himself wrote, "The presence of much suffering agrees well with the view that all organic beings have been developed through variation and natural selection." That said, it has become fashionable in light of recent discoveries in biophysics to say, "Life is more perfect than we imagined," which is also the title of a frequent and popular lecture given by William Bialik, a Princeton biophysicist and National Academy of Science member. It's easy to believe biological systems are technologically inferior to human-engineered systems for various reasons. First, there is, as Darwin pointed out, lots of suffering, blundering, cruelty, and waste in the world. Second, human-engineered systems often outperform biological systems in certain, but not all, metrics. Third, a far, far more subtle but significant issue is something illustrated by Shannon's noisy channel coding theorem. That is, communication systems that are optimized for compactness must, as a matter of principle, allow large numbers of errors to enter a communication and/or storage system that are later remediated by error correction systems such as Reed-Solomon and Bose-Chadori-Hakogen schemes. By way of comparison, DNA has numerous ongoing breakdowns and errors, but DNA repair mechanisms correct almost all of those errors. There's an entire journal dedicated to DNA repair. So, as a rule of thumb, the more complex, compact, and high-performing a system is, the more prone to breakdown and errors it will be. Hence, we can be misled to think an otherwise high-tech device is deeply flawed. With that in mind, here is one example of a feature in biology that was previously viewed as clumsy and blundering, but then later termed as ingeniously designed. The phrase ingeniously designed was used in a PNAS paper addressing specifically the backward wiring of the human retina. This is a case example of something previously viewed as clumsy and blundering, only to be later deemed ingeniously designed. As a former engineer, I love that phrase, ingeniously designed. Now fasten your seatbelts. In the interest of time, I now have to go into machine gun mode and fire off a long list of examples, which should be easy to track down by replaying a recording of this talk in slow motion. Life is more perfect than we imagined, illustrating fitness through physics. Some superior technological secrets have come to light from a deep-sea organism. Modern technology cannot yet compete with some of the sophisticated optical systems possessed by biological organisms. Next, bird quantum magnetic compass. The bird quantum magnetic compass operates at the limit of the quantum limit. Next. Exciton transport is 100% efficient in photosynthesis, which human engineers can't ever exceed in solar cells. Limosa lapponica can fly 9 days straight with no stops or rest or sleep, 11,680 kilometers, weighs 10 ounces. We can't make anything today so energy efficient. Next, the human brain operates at 25 watts. A comparable silicon-based machine would require 10 million watts. The brain operates at the extreme limit of thermodynamic efficiency defined by the Landauer principle. Therefore, human designs will never do better as a matter of principle. Next, enzymes are biocatalysts that operate with catalytic efficiency better than anything we can build from scratch, especially enzymes like topoisomerase, which I happen to have published on. Next, sharks can sense electric fields generated in the muscles of its prey. This is at the limit of what is physically possible. The eye can detect a single photon, the nose a single molecule. Therefore, human designs cannot do better as a matter of principle. Natalie Angier of the New York Times, after interviewing several biophysicists, said that biological systems couldn't get faster, more sensitive, or more efficient without first relocating to an alternate universe with alternate physical constants. Emmanuel Todorov at University of Washington mused, "You might say, well, the human body is sloppy, but no, we're better designed than any robot." This also agrees with the work of Stuart Burgess, professor of biomechanics and robotics of 40 years, who incorporated award-winning biologically inspired designs into robots and spacecrafts. And the final frontier of excellence in biological systems is in the areas of self-assembly, self-healing, and von Neumann self-replicating automata, areas in which human engineers cannot even begin to compete. When I briefly, and I emphasize briefly, worked in the field of biomolecular engineering and nanoengineering, the topic of self-assembly and self-healing was an acute, difficult, and unsolved problem in nanoengineering, at least as far as human engineering goes. But obviously, it has been solved in biological systems. Nobel Prize winner Sidney Brenner said von Neumann's automata should be central to biological theory. The best examples of Turing's and von Neumann's machines are to be found in biology. Nowhere else are there such complicated systems. Code script must form the kernel of biological theory. So, let's pause. So, how do biophysical benchmarks relate to the notions of fitness and adaptation in evolutionary biology? This is really the central question in my presentation today. These physical benchmarks define the maximum possible level of fitness and adaptation in the engineering sense. The conflict between the prevailing definition of fitness in population genetics versus the engineering definition of fitness from physics came to a head when I worked on the problem of fitness maximization, especially while studying Grodwall's extraordinarily compelling paper, The Theory Was Beautiful Indeed, Rise and Fall and Circulation of Maximizing Methods in Population Genetics, 1930 through 1980. Nowhere in my reading of this historical magnum opus was there any mention of biophysical benchmarks used in determining maximum possible fitness. Yet obviously, the bird quantum magnetic compass has maximized its performance, dare I say fitness, in magnetic sensing. Same for excitons in photosynthesis, energy efficiency of the human brain, etc. Now, to illustrate this, consider this rhetorical question. How do engineers determine if something is adapted to fly? If one asked an engineer how a bird or butterfly is adapted to fly, he would say it is adapted to fly because its parts and its organization are consistent with the engineering principles of flight. Basically, for something to be adapted to fly, its wings must be able to generate enough lift to overcome the force of gravity. Its engines must create enough power to enable the airplane to overcome the drag caused by the air so its wings can generate enough lift, etc. That illustrates the engineering view of the meaning of adaptation. And unfortunately, it doesn't at all involve adaptation by appealing to reproductive efficiency. From numerous experiments, it now appears the engineering viewpoint of fitness is anti-correlated with the population genetic viewpoint of fitness. These experiments serve as counterexamples to the ultra-Darwinian viewpoint as expressed in popular books such as The Blind Watchmaker and Darwin's Dangerous Idea. Now, ironically, I mean really ironically, Darwin's Dangerous Idea advocated the view that biology is engineering. And this is important because engineers now are extremely interested in biological systems to help solve problems in their own domain of work. And hence there is potentially a large amounts of money to be invested in the study of biological organisms in order to inspire and solve engineering problems. And if I may point out an important aside, Wolf and Kunin wrote, quantitatively, the evolution of genomes appears to be dominated by reduction and simplification, punctuated by episodes of complexification. Punctuated complexification. I like that idea, but unfortunately it may not be subject to repeatable experiments. That said, the idea of punctuated complexification may be supported by the notion that proteins are instantiations of Platonic forms. Thus, there may be no gradualistic Darwinian route to evolving certain proteins. When I look at amino acid residues of collagen on the left and human zinc finger 136 on the right and colorize the residues, it suggests to me that there is no common ancestry from a single ancestral gene locus for all proteins, nor gradual stepwise route for their emergence. This problem would seem even more acute for proteins whose function is critically dependent on a multimeric quaternary structure, such as in topoisomerase. Thus, this reinforces the notion that proteins instantiate Platonic forms. Additionally, consider this experiment by Van Hofwegen et al., which showed that the DCUS protein in the long-term evolution experiment never recovered function over 80,000 generations following a mere 5 nucleotide deletion event. This experiment supports the anti-correlation hypothesis, but I would hope for hundreds more of such experiments in the future. In some cases, reductive evolution may be powered by natural selection, such as in declining IQs, as indicated by this study. Again, this reinforces the anti-correlation hypothesis. Even more pointedly, the famous long-term evolution experiment shows the anti-correlation between engineering fitness and population genetic fitness. Cooper and Lenski showed fitness increased in one environment and declined in multiple other environments that tested catabolic versatility. And this is strong evidence again in favor of the anti-correlation hypothesis, the anti-correlation between engineering definitions of fitness and adaptation versus the population genetic definition of fitness and adaptation. And beyond the fact that we are now in the 6th great extinction, the biosphere may be in an era of reduction and simplification. And using Wolf and Kunin's phrase, genome reduction. Genome reduction is the dominant mode of evolution. Declining genetic health over time in populations is a testable prediction, at least in principle, that could lend support to the anti-correlation hypothesis between engineering and population genetics. But in the meantime, let us all work together to preserve the ingenious designs in nature, composed of organs of extreme perfection and complication that constitute endless forms, most beautiful and most wonderful. Thank you. Questions?